All right. Let's see. Are you receiving what I'm sharing?
Yeah, we can see your
Okay, good. Sorry, I'm not super familiar with Teams through the browser. All right. Let me come on. Okay. All right. So this talk is going to be a pretty short overview of the work so far we have done on part 3 of Connected Systems API, involving the PubSub architecture here, and specifically its application to MQTT. I will go over a few things in the first half of this presentation, and then I have a little short demo with a couple of actual physical devices that I hope you guys find fairly interesting. So with that out of the way, let's get started. So if you're unfamiliar with OGC API connected systems, though I believe most people here are going to have at least a cursory knowledge of it, what it is mainly trying to do is provide a REST API that wraps a lot of the SOS architecture, as well as with part 3 providing a little bit easier asynchronous platform to retrieve all of that data. It integrates with, basically anything within the OGC catalog of the big catalog of things that I kind of like to call it. Let's see, moving on. So right now the spec is structured this way, with part 1 being feature resources and part 2 being dynamic data. These two have already been published. PubSub, which is what we're talking about today, is still in development. Right now, everything that I'm working off of here that is actual working code is sort of in a pre-draft state that we hope to move forward with the community's input, and this being kind of a guiding, an initial guiding light, so to speak. There is a document currently that Alex Robin created for us that a few of us have gone back and forth with in the SWIG for those meetings to kind of refine it a bit to get it to where it is right now, and I'll talk about that in a minute. Initially, so part 4 initially was actually wrapped into part 1, but due to the size of the spec and the specifics of it, got broken into its own part. And then part 5, I believe one of my coworkers gave a talk on it earlier today, and it's still very early days, but it is binary encodings for things like protobuf flat buffers, things of that nature. Okay, so moving on to the more specifics here. PubSub is generally just a messaging pattern that relies on a broker to fan out messages from anyone that publishes messages to that broker. This is good for any number of reasons, but it allows them to be independent in such a way that they don't necessarily, a publisher doesn't necessarily have to know anything about anyone who will be receiving its data, other than, especially as part of something like connected systems, that it is speaking a correct format, so to speak. In this case, with what we're using today, that's going to be SWI-JSON, but other formats are supported, and I'll get into a little bit more detail on how we're kind of handling the content types, or at least what the plans are for handling content type negotiation, because one thing you may know about things like MQTT is by default there's not really content negotiation in the way that there is via HTTP. Let's see. So PubSub and OGC API connected systems, the main thing here is that it inherits the OGC standards from PubSub, from that working group, and it provides two different formats for messages, because there are inherently two different type of messages that we are looking at presenting over MQTT or whatever other pub sub broker that you have. And those are going to be Cloud Events version 1.0 formatted messages, as well as direct connected systems API encodings. So again, like GeoJSON, SweJSON, SweetCSV, the binary encodings for part 5, so on and so forth. We get a couple of benefits in the topic hierarchy, especially for MQTT, because they support wildcards, and that will allow a user, to subscribe to like all system events or all system resource events in particular to see, say, when a system comes online or not, or when new observations are created. And you might be thinking, well, won't things get flooded every time an observation is created, especially for high throughput things such as like a video camera or a LiDAR or something like that? And you're right, and we did think about that, and I'll get to that in a minute. Also, the security model for this, it does follow the HTTP access control. Obviously, it's up to the individual implementers to make sure that this happens. But in general, say if a certain topic is off limits to a certain user, then the ACL and the pub sub broker should do the same. So I touched on this a little bit. I said there were two message types, and that's true, but there's sort of a special case for resource events. Basically, regular resource events, these are the things that are wrapped in the cloud event spec. They notify when any resource on the network is created, updated, or deleted. These are only published by the server, so individual clients won't be able to publish things here directly. Rather, they will send data messages, and the server will then pick up on the data message and create a resource event for that in the event, particularly in the event of like observations being added. And on the subject of observations, we have these batch resource events. So what a batch resource event is just an aggregation of particular types. Like right now, all that we're working with is observations, and what it will do is it'll just provide you a time range and a link to all of those observations, so you can filter on that time range. This will let you at least know that a data stream is producing observations and that it is alive. But this gives you a good chance to tell, so hey, data is coming across, and it exists in this time range. I would like to pull that in. That being said, with the way MQTT works, we don't really envision it working in a vacuum necessarily, being the only interface that a user will have into connected systems. It very much works hand in hand with the REST API. In particular, the REST API is very, very good when you need to make one single call and do kind of a first round discovery or something like that. Then the last message type is just a resource data message, and these are going to be any of your standard connected systems API encoded payloads. So again, SweetJSON, GeoJSON, SweetCSV, SML, all those things. So a little bit more in depth on what a resource event is going to look like. This is just left side here is the text definition with an example payload on the right. You can see that they have which version of the cloud event spec that they are associated with, what the type of event is. So we're using the org.ogc.api.consys package path essentially to delineate what these are. Then you can see this is a data stream event, and a data stream was created. A source, which is just a link to the CS API root URL. The subject is going to be the canonical URL. An ID is just a UUID. Time is a timestamp, and then there's an optional data field. This one I need to discuss a little bit more with some of the other members of the working group exactly what we plan on putting in there. But it is there and it is available. So batch resource events, again, they share all the fields really that a regular resource event does. However, you'll notice there is a time range and account. This is mainly because we were concerned with potentially just overwhelming a network with too many published events at once. And this is at the current time what we have settled on as a reasonable happy medium, because I understand and we all understand that a lot of devices that are using things like MQTT are going to be low powered. As you'll see today, I'm running stuff on a Raspberry Pi that's like 8 or 9 years old, and a Raspberry Pi Pico, which is just a little bitty tiny microcontroller. So those things, when they are subscribed, though, obviously they don't have to subscribe to these things, but in the event that someone does subscribe to it, you don't want them to be sunk having to process all these events coming through. Though that being said, that is one of the good things about PubSub, right? Is you do subscribe to the things that you need, and you don't have to subscribe to anything else. To kind of touch on that point again too, it does also free up a lot of server overhead to not be publishing those events as they come through. Okay, so let's see. So the topic hierarchy here, these mirror very closely the path that the REST API has. So top level systems IDs, one difference you'll notice is there's a node ID at the beginning. This is just to identify the broker itself in cases that there exist more than one that you are publishing to kind of in a cluster. But beyond that, you have the pretty standard systems, the Nokia system ID for a specific system. You get the nested topic hierarchy, as well as sort of top level paths for things like data streams or control streams as well. They can be accessed in either way. We do have wildcards available. They follow whatever the rules for whichever broker you're using. In the case of MQTT, that's the plus and the pound sign, or Octothorpe if you're feeling fancy, I guess. Wildcard system. This is just a couple of examples here at the bottom. For data topics. So this is where we kind of diverge a little bit from the regular connected, the REST API, because it works out best this way to have a data endpoint here. There was a little bit of back and forth between actually having data be its own level in the topic hierarchy. The problem with that is that especially for the way MQTT works, if you subscribe at that top level, you're going to get literally everything underneath it. And again, like I talked about earlier, you're going to get absolutely hammered by messages if you do that. So we sort of took the lesser of two evils, so to speak, and put it here on the end. One thing that isn't being shown here, so for content negotiation purposes, we're currently playing with the idea of having content types be a lower level in this hierarchy. And we understand, that does differ from regular connected systems API endpoints. But because a large number of pub sub brokers don't have like a full-fledged content type negotiation system, that's what we're thinking works the best so far. So for an observation, just to give probably the most relevant example, if you were looking at that top observation endpoint, you would have a topic that would be that format / SWI-JSON to get SWI-JSON encoded payloads. Not a ton of overhead, and it would technically allow you to get all of the formats at once. How that gets presented, I think a couple of us have a little differing idea on the payload there, but for now, what that would present itself as would just give you, say there's 3 different encodings, it would give you all 3 observations as they got published, assuming that the server was publishing them and they were valid formats for that observation type. So this is a diagram based off of some work that we are doing internally within GeoRobotics that we have this concept of a federator, which exists for situations where we need to cross a secured boundary, meaning there are nodes that exist behind that boundary, and the person who controls it, for whatever reason, is unwilling to let us open a lot of direct connections to sensors that exist out there in the world. Those just generally, this is just a security concern. What this lets us do then, so the federator here is running a broker underneath it, and that broker only has sort of one point of ingress into this secured boundary versus having, n number of connections needing to be made to the outside. And by using MQTT for this, which is what we're doing, it lets a viewer on the opposite side that has controls send it to this what we have dubbed a commander node, and it will publish those commands out through this pipe to the federator, and then that is associated with a sensor on, say here, remote A, with this little robot that that you can then tell it, hey, go to this waypoint, so to speak. So that is something that we are testing out currently with MQTT and OSH Connect for Python. I didn't throw a slide in on it because I've talked about it before, and I'm sure you guys are probably tired of hearing about it. But OSH Connect Python is just a Python library that I wrote along with help from some of our teammates that provides a pretty easy interface for anyone using Python to talk to, in particular, an Open Sensor Hub node that is using Connected Systems API, though it should be fully compliant with any Connected Systems API server. Moving on. All right, so I'm about to get into the demo since we're getting fairly close to the end here. I apologize if you can hear my dogs barking. They have found a squirrel, I think. So this demo is going to do a couple of things. Some of it's going to happen a little bit invisibly, but I'll kind of try and walk through them the best I can. I'm going to set up a broker connection. You'll see that this says MQT and WebSockets. The reason being is there is some video involved, and I'm using a WebSocket connection to bring the video in, just because wrapping the individual video frames and encoding them in some other format is not super easy when you're having a Raspberry Pi do it. So that's going to be a mix of the two, but it does show, I think, that there's some interplay between the two systems. Let's see. I'm trying to think if there's any of this that's worth talking over. I don't believe so. Okay, so I'm going to change the screen that I'm sharing, and I'm going to go through a couple of different dashboards, mainly because I wanted to give a little, a wide variety of, potential use cases for this. First off, I'm going to show the Open Sensor Hub dashboard. Give me just a moment while I swap over to a different tab. Let me stop sharing for now. And I will share a window. I'm hoping. Okay, so I have a permissions problem. Let me open up a new window because Chrome isn't allowed to see Firefox windows from here. I apologize for that. While I am doing this, does anybody have any questions for me so far? Okay, let's see. So that sensor hub / API. Nope, that one's at sensor hub / admin. Okay. All right, I apologize again for my lack of preparedness. Okay, so can everyone see this?
Yes, we can.
Okay, good, thank you. So you'll notice that there is one sensor running here that is the actual, again, what I was talking about, a WebSocket stream for the Raspberry Pi camera. You'll notice that there are no other sensors defined here, and that is because they are coming over as connected systems things. So this is a way for us to view system instances that are registered via connected systems. So things in Open Sensor Hub that run as a driver module, they do also appear in here. So this is that Raspberry Pi camera. I have a gateway that's running here. So this gateway is actually pulling things back off of Open Sensor Hub. And by off of Sensor Hub, I mean the Connected Systems API REST server and the MQTT broker. What it is doing is pulling in that video stream, and it's actually running some motion detection and facial recognition, and then publishing those as observations back up to connected systems. To demonstrate that here, so there's face detections, per frame metadata, so like mean luminance, average RGB, that sort of thing. Then motion regions. There is a PTZ setup. So this little I'm sure a lot of you have seen them, the little Raspberry Pi cameras. I have one of those running right here that is controllable. And then interestingly enough, actually this entire demo, I have a control panel that I can send commands to this node and bring it up and down. And those themselves are routed through here as commands. So with that, let me first pull up the dashboard here. So it is running here. Okay. So you guys should be, I think, looking at my floor right now. But this is a dashboard that is pulling stuff in from the Open Sensor Hub node that, again, is a combination of MQTT and WebSockets for the video stream. And this is a little Raspberry Pi camera, so it's not going to be particularly effective as far as things like motion detection because there's a lot of noise in the image. And I'm not doing really any extra processing aside from running the little OpenCV detection on it. I'm not doing any kind of good image cleanup. On the right side, you'll see that there's a thing for face detections, a timer for when it was last seen, the number of motion regions it's detecting, the PTZ telemetry, and frame metadata, as well as just the topology of all of the URLs for where.
Sorry, all we can see is the form. So we're not seeing what you're referring to there. So I suspect you're probably just sharing a window and not the full screen.
We see Open Sensor Hub.
You see Open Sensor Hub. Let me see if I can get it to play nice with. I think I may have just had a tab. View dashboard. Can you see this now?
We see a fan. I think that's looking at your roof or your ceiling. Yeah.
And your
You
hand.
should be able to see me waving now. Okay, cool. So since my webcam isn't working, I'm going to actually use this camera to show off a little bit of stuff. But so this is a Raspberry Pi Pico attached to, I'm sorry, this is very difficult. This thing does not have a wide field of view. This is a little joystick controller that is connected to just a small microcontroller, and both of these are speaking connected systems, but when I move it, it can control this camera. What happens right now is it likes to go to sleep on me. So it's going to reset here. So when I push up on this controller, it sends commands.
So it's out of view. Okay, so right now it's in view. Okay, yeah, now it's in view.
So basically, this controller is just sending publishing events to the connected systems broker that's running all in a Docker container on a separate machine. And this microcontroller that's right here, it's kind of hard to see in this frame, is publishing those commands. It does not know anything about the Raspberry Pi that is providing this video and PTZ data. It's only talking to the broker. There's no direct connection between them. But so this is just a little example of kind of what you can do with some of this stuff in a more hardware involved setting versus something a bit more abstract. I think I know a lot of times we deal in abstract stuff, but I thought it would be fun to put together a little hardware setup. With that being said, we're really close on time. I'm sorry I didn't leave as much as I had hoped for questions. If you guys have any, please feel free to reach out to me. And if you have any now, while we still have time, I'm more than happy to answer them. But otherwise, that has been my time slot. It went by much faster than I expected.
Thanks, Ian. Are there any questions for Ian or comments from the room or from online? Okay, so Ian, with regard to your setup there, what you had on the Open Sensor Hub dashboard.
Mm-hmm.
Was it the dashboard? No, it wasn't the dashboard. It was the other screen, the form.
Yes.
So I noticed you've got something to do with FFmpeg there, and below you've got I saw something to do with pixels. Could you please just explain to us what was on the screen there, particularly with regard to pixels and FFmpeg?
So
it wasn't that it was the view. I think you were setting up the subscription, I think.
This one?
Yeah, that one, that one. Yeah. Okay. Yeah, that one.
Yeah, so actually, within Open Sensor Hub, we do encode video data as an array of pixels.
Yeah.
So that's just sort of a visual, like as best as we can get approximation of the data. Obviously, what you want to see really when you're looking at a video stream is an actual image.
Yeah.
Um, so this is just kind of showing a little bit of the output structure as what it's actually encoded like. So it's uh, uh, 1280 by 720 JPEG image.
Okay. Okay. I understand it now. So that observation outputs thing at the, it's like it's kind of like the schema or the structure of what the outputs are going to be.
Uh,
Um,
Basically, for other sensors, there will actually be a you'll actually see values come across through here. But again, for video data, we're not providing the actual full array of the pixel values because
yeah.
that would probably destroy our dashboard.
Yeah. Okay. Okay. Understood. Understood. And you've got a SenseML thing there as well. So that's just for configuring the sensor, right? And
Yes.
so you provide a SenseML document there describing the this FFmpeg sensor, and and then how is it then advertised at the front end of the connected systems API? Are you able to show us an example there?
Sure. So in Open Sensor Hub, we have service modules, and so we have a basic connected systems API service that runs, and you can set up sort of um, which sensors are exposed through that. And so the initial connected systems API service is solely the REST service as well as some provisions for WebSocket connections. By default, we push everything that goes into our federated or aggregated database for all sensors, and then we run a HiveMQ server, a HiveMQ broker rather. Um, that's an underlying layer because we've done some other MQTT stuff in the past before part three
Yeah,
was completely in the works. And then so we have a bridge now that provides the topics for everything, and it pulls it pulls in all of the observations from the event bus that exists within Open Sensor Hub. So we have an internal event bus that advertises systems and data streams and observations and control streams and commands and all that. And then it just as the events internally get triggered, they they get picked up by the bridge because it is internally subscribed to those events and it
yeah.
publishes them out onto the broker.
Okay. Okay, understand. Okay, all right, thanks. Any questions or comments? Yeah, Rob.
Thanks, Gary. Hi, I'm Rob Smith from WebVMT. So
Okay.
I'm in the video side of this. But my question is, and you may have already explained and I haven't understood, are you actually threading the video frames through the MQTT server, or are you just referencing the video?
I'm just referencing the video on here. So you could, especially the way that we encode the video frames individually, you could send them across MQTT. For the purposes of this demo, I just didn't really have time to get that working in a way that I was satisfied with. So um, it is published via just a WebSocket connection. However, um, it is retrieved by the gateway that I was describing. The frames are actually retrieved individually um, over MQTT.
So you've got a frame count or something, and then a video stream, so you can work out which frame it is, and then which pixel in that particular frame.
Basically, yes.
Yeah, okay. Fantastic. Thank you. That was the point of interest. I've looked at things similar and then just thought this is going to overwhelm the MQTT server. How would I do it? And that was the thing I had in mind. But you've really come up with the same answer. So that's encouraging. Thank you.
I'm glad I could help.
Thank you. Any other questions or comments? Okay, so just one observation. So there was a slide that had a series of topics on it. And one thing that came to mind when I saw that was, so we have within the OGC a standard called OWS Context, which was developed to make it possible to create what are the common operating pictures. So effectively, each one is like an ingredients list or a recipe. It's like a recipe, and basically you say, you know, you want to create a specific common operating picture. Here's the recipe. So here are the web services and the feature collections and the maps that need to be obtained from these web services, etc., etc. So it kind of works that way. So there's a new effort to try and update that to include the OGC API standards, because at the moment, OWS Context is primarily focused on web service standards. So when I saw the list of topics on the screen early on, I wondered whether PubSub gives us a way that we might be able to say, you know, in a common operating picture defined by this context document, you can, you know, you get your feature data from those servers and your notifications, as well as from that other server and the topics to subscribe, such that if somebody gets that context document, uploads it to the, you know, to the GIS or similar command and control system, they not only get the you know, the environmental data, but they also get subscribed, or they get access to the you know, to the channels, etc., that have been advertised by that PubSub service. I don't know if you understand what I mean?
Yes, I do. So, or at least I believe I do. We've actually had a little bit of a conversation about this internally to essentially have an updated version, and I believe we're referring to the same thing. I don't remember what it was called. I wasn't around in OGC at the time. I don't believe for these original sort of visualization definitions. But Chris Tucker and I have talked a little bit about being able to do that internally, so that we can really quickly deploy some of our visualizations. And we do something similar to that effect, actually, with our own viewer. I was going to demo it today, but I ran way too long. But it has the ability, it does save off a schema that you can, that's portable and you can reload, and it'll actually reconnect to any, you know, predefined brokers and stuff like this by virtue of using that saved off. We just use a simple JSON file for it, but we want to incorporate that as part of you know, something that is more of a standard, so that anybody could use it to you know, to subscribe to like a broker of you know, some sort like this that is out there.
Yeah, let me just quickly grab the screen for a second so I can show you what I'm referring to. So the OWS context standard, as you can see in the name OWS, it was initially directed towards web services. So we're looking to update it. So there's a conceptual model which is obviously a high level, but as for the physical models or the encoding. So there's an atom and a GeoJSON encoding. For the sake of simplicity, I'll just go for the atom one, just so I can show you what the structure looks like. So effectively, the idea is that you'd be able, within a context document, you'd be able to reference all of these things and layers or data sets from those things. And then client application passes that document and then constructs the view or the visualization on the client application. So I don't know if there's an example. Right, yeah, and then you can see examples. I'm looking for one that has WFS on it. WFS. Right, okay, here's an example. So, and then you can see here where there's this offering thing where you've got to get capabilities, and then there's a get request, and then it tells you what layer to get. So relating that to PubSub, what I'm wondering is what information we would need to, to capture or to represent in order to get the topics as well as the channels and etc. Well, I mean, we don't have to solve it now, but I think what I'm trying to do is just to check if that is a valid connection that I'm making between context documents and PubSub within this context. But it sounds like it is, right?
Yeah, I believe that is definitely a valid way of looking at it.
Okay, sounds good. So I guess we'll circle back and at some point to discuss that with the standards working group. Okay, any other questions or comments for Ian? Okay, hearing none, let's thank Ian for an excellent presentation, please.